Some places on Earth were never meant to hold human structures. Cliffs collapse, oceans shift, mountains crack, deserts bury roads, rivers push with impossible force. And yet, humans still built highways, bridges, islands, tunnels, dams, and canals right through them. Today, we're counting down the top 9 engineering projects built in impossible places. Stay until number 1, because the final project cut through a continent, connected 2 oceans, and became one of the most dangerous shortcuts ever carved into the planet. Dubai did not just build beside the sea, it built land on top of it. From above, Palm Jumeirah looks like a giant palm tree floating in the blue waters of the Arabian Gulf. Palm Jumeirah was built using enormous volumes of sand dredged from the seabed. Engineers fought waves, erosion, and water pressure to force sand into real estate. It is geography redesigned. The island is protected by a 10-mile breakwater. Without it, the ocean would slowly attack the sand structure. It is constantly being defended from the sea. It is a symbol of ambition, showing the world that Dubai was willing to challenge the coastline itself. But how long can we keep nature from take it back? But building an island is one thing. The next project placed a road through one of the most dangerous mountain landscapes on Earth. This is not just a mountain road, it is a lifeline carved into a place where gravity never stops working against you. In some sections, the road looks less like a highway and more like a scar cut into the side of the earth. Every mile feels exposed. Every turn feels like a negotiation with the mountain. Imagine a narrow highway twisted between Pakistan and China, squeezed between enormous mountain walls and deep valleys. Trucks crawl along cliff edges while clouds drift below the summits. Every turn is a test of nerves, but the mountain is only the beginning. Next, we look at the brutal human battle to build this road. During construction, workers had to drill through solid rock, carve paths along unstable cliffs, and deal with sudden landslides, falling boulders, and ice. The project took nearly 2 decades. Tens of thousands of workers operated in some of the most dangerous conditions on Earth. Building this road was a matter of persistence against a mountain that never stops moving. For the workers, this was a brutal human effort. Men carved through rock in thin air, knowing the mountain could answer at any moment. For the region, it changed everything. A mountain that once divided movement was turned into a lifeline. But if Karakoram clings to mountains, the next project hangs above empty space. The Duge Bridge does not simply cross a valley, it crosses a void. High in the mountains of China, the bridge stretches between cliffs like a thin steel line drawn across the air. Its deck stands 1,800 feet above the valley floor, close to the height of a 180-floor building. Below, vehicles look like tiny dots, suspended in open space. Anchored into steep slopes, this massive machine carries tens of thousands of tons. It must survive extreme winds and constant gravity while connecting distant communities. It turned a journey that once took hours into minutes, placing a road in the sky. But while Duge conquered height, our next project had to conquer the ocean depth. Next, we move to a 30-mile transport machine that disappears beneath the sea, the Hong Kong-Zhuhai-Macau Bridge. This is not just a bridge. It is a 30-mile transportation machine built across and beneath the sea, connecting Hong Kong, Zhuhai, and Macau. Imagine driving across open ocean with water stretching as far as you can see. The road feels like a runway placed on the sea. Then suddenly the highway begins to descend. The bridge disappears, and the road dives into an underwater tunnel. Above you are ships. Around you is the sea. Ahead is a hidden corridor built from 33 massive concrete segments joined beneath the water. Each had to align with extreme precision. Even a small error could have serious consequences. This is not one problem, but many impossible problems stacked together. Next, we uncover the hidden risks behind this massive structure. During construction, investigations once revealed suspected falsified concrete test results, turning the project into a reminder that danger does not only come from nature. Sometimes the risk comes from human systems, quality control, oversight, and the temptation to cut corners. On a project this massive, trust in materials is not a detail, it is survival. The bridge dramatically changed travel between major cities in the Pearl River Delta. It turned a complex regional journey into a direct corridor. But for every driver crossing it, the hidden story remains below the wheels. Enormous structures in marine conditions where one mistake or oversight could become a disaster. Next, we move to America's Southwest, where engineers built a concrete wall against the Colorado River, the Hoover Dam. Hoover Dam was not built in an easy landscape. It was built by forcing a wild river to step aside. At the border of Nevada and Arizona, the Colorado River cuts through desert canyon walls. Between those walls stands Hoover Dam, a massive concrete barrier rising more than 700 feet high. From below, it looks like a man-made cliff. From above, Lake Mead presses against it like an inland sea. During construction, workers hung from ropes along canyon walls, drilling and blasting loose rock while suspended above the site. The environment was hostile: heat, rock, and height. Engineers had to redirect the Colorado River through enormous tunnels to build the structure that would eventually control it. A mistake could flood the entire zone. Next, we look at the incredible scale of the concrete mountain built to stop a river. More than 4 million cubic yards of concrete were poured into the dam, creating a structure strong enough to resist the pressure of millions of tons of water. That is a concrete mountain built to stop a river. More than 20,000 workers took part. Many faced extreme heat and constant risk. The base of the dam is more than 600 feet thick. This is an energy fortress in the desert. Hoover Dam transformed the region, providing flood control, power, and water for millions. But behind the icon is a story of men working in deadly conditions. But Hoover Dam holds back one river. The next project protects an entire country from the sea: the Delta Works in the Netherlands. Some projects are built for transportation or power. Delta Works was built so a country could survive. Along the Dutch coastline, massive structures stretch across water channels like a national shield. The Netherlands has fought water for centuries, but Delta Works was born from disaster. After the North Sea flood of 1953 killed nearly 2,000 people, the country began building a system to ensure it never happened again. This is not one wall or one dam. It is an entire network designed to tell the ocean, "Not today." It manages water through an entire landscape, protecting low-lying areas from powerful seawater flows. But this is not a static wall. Next, we look at the precision engineering that makes this system react to the sea itself. Some barriers remain open for ships, but when a storm surge threatens, the gates close. The sea is held back by moving steel and engineering precision. This is not a static wall. It is a system that reacts. For the Dutch, water management is national identity. The country exists because they spent centuries draining and defending land. Delta Works is the modern expression of that struggle. A memory of disaster turned into one of the most impressive flood defense systems on Earth. It is geography defended by human will, but the Netherlands fights the sea from below. The next project climbs into the sky above clouds and wind: the Millau Viaduct in France. The Millau Viaduct looks less like a bridge and more like a road suspended in the sky. In southern France, tall white pylons rise from the Tarn Valley like giant needles. When low clouds fill the valley, the bridge appears to float above them, as if cars are driving over the sky itself. From below, the scale is almost difficult to process. The valley is huge, the structure is slender, and yet the bridge seems to cross the landscape with impossible calm. It is a masterpiece of light and strength. Engineers had to create a structure strong enough for wind, but light enough to span the valley. The steel deck had to be guided across the sky like a giant metal thread. But Millau reaches into the clouds. The next project cuts through a mountain in the Himalayas, where every meter is dangerous: the Atal Tunnel. The Atal Tunnel was built where mountains do not welcome roads. Hidden within the Himalayas, the tunnel cuts through a massive mountain like a dark concrete artery. Outside, steep slopes, snow, rockfall zones, and landslide-prone terrain surround the route. Every meter here was a battle against the earth itself. Inside, vehicles travel for miles through an enclosed corridor beneath the weight of the mountain. The entrance feels like a doorway into geology itself, from cold mountain air to a controlled environment. Next, we look at the engineering that allows this tunnel to breathe. Built over 10 years at high altitude, the Atal Tunnel is nearly 6 miles long. Engineers fought groundwater, structural stress, and landslide risk to drill through hard rock. A tunnel like this must breathe through complex ventilation and protect drivers with emergency passages. It is a controlled environment, built inside an unstable natural one. It shortens travel by about 29 miles, turning a dangerous, weather-disrupted mountain road into a reliable lifeline. For the region, it changed everything. But number one goes even further. It did not just cross a mountain, it cut through a continent and changed global trade forever. The Panama Canal. Number one is the Panama Canal, one of the most ambitious engineering projects ever built in an impossible place, and one of the most important shortcuts in human history. Imagine a massive container ship entering a narrow concrete chamber in the jungle. The gates close. The water begins to rise. Slowly, the ship lifts as if the earth itself is raising it by hand. Then the next gate opens, and the vessel moves forward through a system of locks, channels, and carved passages. On one side is the Atlantic, on the other is the Pacific. Between them is a canal cut through Central America, turning a continent into a machine. But this shortcut came with a brutal price. Next, we look at the human cost. But this solution did not come cheaply. During the construction era, disease and accidents claimed about 27,000 lives. The Panama Canal is also a monument to human cost. It did not simply make travel easier, it changed the map of global trade and naval strategy. It solved an impossible problem by reshaping the relationship between geography and power. The Panama Canal is proof that humans can look at a map, find the impossible line, and carve it into reality. It is one of the most daring engineering systems ever created. Nature creates limits, and humans test them. Each project tells the same story. Sometimes, the result changes the world. Subscribe for more cinematic rankings about the most extreme places on Earth.